Hello, my name is Zakaria Gali, anak Peter, metric number 72029. Okay, for my part for this project is part A, which is the introduction, part B, which is process and justification, and part E, which is the optimization. I would like to start my presentation with the introduction. Why our group choose the table lamp? First of all, the table lamp consists of several components which are made from two main materials, which is metal and polymer. It also involves all the four manufacturing process, which is casting process, joining process, metal forming process, and non-metal forming process. Metal forming process are involved in base parts where die forging is used to produce this part. For joining process, mechanical fastening by using bolts to secure the elbow joints, and for metal forming process, rolling extrusion can be seen in the base joint, strut, and spring parts. Non-metal forming, which involves injection molding, is done for the socket and for the base support, which is made from polymer for this part. Here we can see our product, which is the table lamp, consists of two main material, metal and polymer, which undergoes the process which I already mentioned before. For the process and justification part, okay, for the first part, which is the base, it is made out of metal. Description: this part supports the arms and shades. Usually the electrical components are connected to it. Manufacturing processes involved in this part is closed die forging. Why this process is chosen? It is chosen because closed die forging has good dimensional accuracy and it has high production rates and also has good reproducibility. Okay, for the second part, which is elbow joints made from metal. Description: assembly and structural support. It allows movement of the table lamp. Process, manufacturing process involved. It involves casting process, which is die casting, and joining process, which is mechanical fastening, which use the screw and bolts. Why this process is chosen? It can produce high production rate. For the third part, which is spring, the spring is made out of metal. It provides traction and tension for the table lamp. Manufacturing process involves a metal forming process, which is extrusion. Why this process is chosen? Because it produces high production volumes and has low cost per part. For the next part, which is head slash shade of the lamp, which is made of metal. It is used to cover the light bulb on a lamp to dispense the light. Manufacturing process involves is metal forming process, which is drawing. Why this process is chosen? It has a high production volume, low cost per part, and easy to shape. For the next part, which is linkage bar and spring bar, which is made out of metal. It is used to connect the back arm to side arm and to connect the spring to the back and side arm for movement. Manufacturing process involved is metal forming and metal forming, which is extrusion. Why this process is chosen? It has high production rate, low cost per part, and easy to shape. The next part, which is socket slash lamp holder, which the main components are made of polymer and metal. It provides electrical connection to the bulb and support the lighting fixture. Manufacturing process involved non-metal forming process, which involves injection molding. Why this process is chosen? It is efficient and process is reliable. And for this part, which is base support, it is made out of polymer. It is used to cover the electrical fixtures inside the case. Manufacturing process involved. It involves non-metal forming process, which is injection molding. Why this process is chosen? It is efficient and a reliable process. And for this part, which is fork made out of metal, this part provides support for the back and side arms and attaches it to the base. Manufacturing process involve metal forming, which is closed die forging. Why this process is chosen? Closed die forging, as we know, has good dimensional accuracy. We can produce high production rates and has good reproducibility.
Okay, so hi, my name is Nur Arisha binti Adiris, matric number 7081. Um, and for my part, I will be presenting about the defects and ways to minimize and the design consideration. So for defects and ways to minimize, we will be focusing on the four processes of manufacturing. For the first process is casting process. We will be focusing on the joint bar, which undergoes die casting. And for the joining process, we use mechanical fastening. And for the spring, uh, uses the extrusion process, which is the metal forming process. And for the base of the table lamp, it is manufactured by using the injection molding, which is the non-metal forming. So we will be focusing on these four processes only. So for the casting process, which is die casting, uh, some of the defects found of die casting related to our product is hot tears, misruns, scab shrinkage, and cold shuts. So for hot tear is when during casting it cannot shrink freely during cooling owing to constraints in various portions of the molds and cores. And the way to minimize hot tear is by modifying mold design and increasing temperature of mold. Misruns is when liquid metal is too cold to flow to the extremities of the mold cavity before freezing and solidifying. So some of the ways to minimize misruns are modifying the mold design, modifying getting system, and modifying molten metal fluidity. Next is scab. Scab is the irregular metallic crust found on the surface of the parts after solidifying. So some of the ways to minimize scab is melting the metal with a flux in a vacuum or in inert atmosphere, and adding a ceramic filter into the getting system. Next is shrinkage. Shrinkage occurs within the product and usually appear at the top of hot spots or isolated pools of hot liquid. So ways to minimize shrinkage is by modifying the getting system with appropriate number of rises and increase local heat dissipation by inserting internal chills, cooling whips, or cooling coils. Cold shuts is when molten metal is poured from two gates. The molten metal may not fuse together at the junction due to low temperature, and the way to minimize shuts is by modifying the gating system so molten metal can flow through narrow path or increasing the pouring temperature to avoid early solidification. For joining process, which is a mechanical fastening, we joined the product parts using bolts and screws. So the defects are cracking and possible corrosion. For cracking, the way to minimize cracking is by drilling threaded holes before the assembly using mechanics. And then possible corrosion. Ways to minimize possible corrosion is using the same material where the parts that needs to be joined together. For metal forming process, focusing on extrusion, the defects that is related to extrusion is internal breakage, surface cracking, and piping. For internal cracking, ways to minimize internal cracking is by controlling the temperature and pressure, modifying the mold design using simulation software, higher friction and higher extrusion ratios during extrusion. For surface cracking, ways to minimize surface cracking is by lowering extrusion ratio and proper control of temperature, pressure, and modifying the mold design before the manufacturing process. For piping, to minimize piping is by ensuring a smooth material flow during extrusion process or controlling friction and lowering temperature of material. For non-metal forming process, focusing on injection molding, the defects found are flow lines, warping, sink marks, and flash. To minimize flow lines, we can increase the injection speed, pressure, and material temperature, adding round corners on the molds where wall thickness increases for a consistent flow rate, or increasing the nozzle diameter to raise flow speed and prevent early cooling. Ways to minimize warping is ensuring the cooling process is gradual and long enough to prevent uneven stresses, lowering the temperature of the material or mold, redesigning the mold with uniform mold thickness and part symmetry to ensure greater stability. And then we have sink marks. To minimize sink marks is by increasing the holding pressure and time for the part's surface to cool down, increasing cooling time, or modifying the mold with thinner component walls to allow faster cooling rate. Flash. The ways to minimize flash is by redesigning the mold if the parts does not fit together, and increasing clamping force to disallow material to flow out, adjusting mold temperature, injection pressure, and ventilation. So design consideration. For die casting, the design consideration is number one is adding sliding cores to the die casting tooling design. Number two is um, draft angle for better demolding, and then adding dimension tolerances. For mechanical fastening, we can drill threaded holes prior to joining on the parts that needs to be joined together. And two is using standard size bolts and screws. For extrusion, the design consideration is limiting irregularities of the design using standard cross section of extruding tool and avoiding extreme changes in section thickness. Injection molding, we avoid undercuts and sharp edges. We use uniform wall thickness and then draft angle for better demolding. Next, I pass back to Zechariah for the last part.
Hello, it's me again, Zechariah Gali Anapita. And for this part, which is part E, the optimization. For the optimization of casting, which is die casting here, the process of die casting can be optimized by automation. By replacing human workforce with automated system, this can reduce the errors during manufacturing compared to manual manufacturing. And secondly, reduce scraps. To reduce scraps, engineers are supposed to stimulate the production in CFD from start to finish to identify the possible errors and the potential solutions. Engineers also can save costs by running the simulation first to identify the production step. Joining mechanical fastening. For this optimization, choosing the right size of bolts and screws to join the parts together are important. If we choose the not proper size of screws and joints, this may damage our product. Using standard size are better and we can maximize the lifespan of our product. For metal forming, which is extrusion, Extrusion can be optimized by controlling the parameters during extrusion, such as billet temperature, mandrel length, convex dial angle, and tooling temperature. For non-metal forming, which is plastic injection molding, to optimize for this process, firstly, using sample parts for quality control instead of a full run production to analyze quality, temperature of polymer, and other parameters that affects the final product. And secondly, short tests, fill rate and pattern, the and pressure curve on the mold design to test the functionality of the mold. Lastly, testing the sample parts for optimization. Okay, that's all from us. Thank you.
Thank you.